Today's tough topic, treated in 2 minutes, has to do with the force it takes to stop something when it's in motion. So the thing I'm going to use here is this bottle. It's got some water in it, right? So I'm going to drop it from the same height, one towards this pillow. Get that on screen here a little bit for you. Right, so no surprise there. Hits pretty gently, and there's not a lot of noise with that, and it does about what you expect it would do. So I drop it from same height onto the table, right? And of course, it's a lot louder. You can tell that there seems to be a lot more energy being given to the table because it's a bigger sound, right? So what's going on here? Well, in both cases, the mass of this is the same, so we haven't changed anything about the bottle, right? And the speed of it when it comes in contact with the thing that's stopping it is about the same too. So if I drop them from the same height, that should make sense to everybody too. If I drop it from the same height, it's going to be going about the same speed when it hits the pillow and also when it's hitting the table, right? So if the mass is the mass is the same and the speed is the same, how come there seems to be a lot more energy associated with dropping it and having it stop when it hits a table? Well, the idea is something called conservation of momentum and impulse. So impulse has to do with the force multiplied by the time over which it takes to stop this thing, right? So there's a force and a time that it takes to stop it, and hopefully it makes sense to you that the force that the pillow uses, right, is smaller, right, and the time is longer, right, for the pillow to stop the bottle, right? When it comes down, it kind of hits and then cushions it and stops it, right, gently. And in the case of the table, right, in fact, in this case, it's even bouncing a little bit, which is a bit of another story. So anyway, let me get to the point of this right now, is that in both cases, the mass and the speed is the same. So what's different is the force and the time. Those two things change which is bigger and which is smaller depending on how you stop something. So in the case of the pillow, maybe you could guess by now the direction we're going, that the force is smaller, but the time is larger to stop the bottle with the water in it, right? And then in the case of the table, the time is much smaller, but the force is much larger. So both things end up being the same thing when multiplied together, the force and the time. But in the case of the pillow, the force is much smaller and the time is much longer. And in the case of the table, right, the force is much larger and the time is much smaller. So this has to do with lots of cases of cushioning, crumple zones in cars, any kind of padding anybody uses to cushion their falls, etc.